Okay, welcome, Cheryl, Robert, and Heather, and Michael, and Maria, Marissa, and Antonio, and Nicole, and Julia. Thanks for coming. This is actually our first regular webinar, although it's going to be shorter than typical webinars because the kind of a lot of the homework this week is the study skill stuff, and I don't think I need to talk too much about that. Really, my webinar is about math. So I'm going to spend time talking about math, and we only have one section to cover. So it won't take a full hour. So this one is probably about, my guess, around a half an hour-ish. Hard to know for sure, but we'll know soon. So that's the plan. And you showed me something, but I didn't see it. I see you have paper. So anyway, that's the plan today. And let me talk about what we're going to be doing. And by the way, somewhere in this webinar, I'll give you the secret word, but it'll be very obvious. You saw me? Let's see, I don't know if you saw me, can't really hear you when you turn your head again, but I'm here. Okay. Yeah, no, I did see you, Nicole. So sorry if I turn my head. I'm going to try and not turn my head. That's really hard to keep your head exactly the same for the whole time, but I'll do my best. So let me talk about what we're, oops, I can keep full screen. Let me talk about what we're going to be doing in terms of this webinar. Unlike the orientation, which by the way, the orientation is absolutely required. You got to watch it. If you didn't watch it live, you must watch it archived, and you must take notes while you're watching it. I need at least 5 pages of notes. You can email me the notes, then I check that you attended, and I don't drop you from the class. Okay, this one's different. This one, you don't have to watch it live. There's no note requirement as long as you watch it on YouTube and see the secret word. And we'll talk about that. So let me go ahead and share my screen so you can all see. Okay, so this is the plan for this webinar. And again, we're shorter than normal. So what we're going to do is we're going to talk about number vocabulary. And by the way, don't think I'm going to teach you how to count to 10. I do, again, there is no true requirements in this class, but I do assume you know how to count to 10. But there's some vocabulary that is a little more subtle that people have trouble with. And what I've done, I've been teaching statistics for over a quarter century, believe it or not. And I know where people make mistakes. So what this class is all about is try to identify the mistakes that are kind of mathy mistakes and deal with them and make sure that you're attuned to the things that some people don't understand. So again, I'm not going to be teaching you how to count to 10, but we are going to talk about things like what's the difference between hundreds and hundreds, because that's a bit subtle. And you might know it already, so if you're bored, I apologize, but it's just day one. Then we're going to get into rounding and talk about proper rounding. Most people remember at least somewhat how to round, but I'm going to talk about rounding so you get the answer right when you got to do an assignment in a statistics class, because there's bad habits that some people make that you may not even know are a bad habit. And I want to talk about that so you don't have to get frustrated when you're doing homework and getting it wrong, even though you did everything right except you had the bad habit. Then I'll talk about scientific notation. And that's something you have definitely at one time learned, but you may not remember it exactly. And it turns out scientific notation in the statistics class, for most statistics classes, is not as important as what I call Texas notation. Okay, that may sound a little weird, but it's what I'm calling it. Any guess? Yes. Any guess on what I mean by Texas notation? And I'm not picking on all those people from Texas, by the way. Any guess? You can say it or put it in your chat box. Either way. No idea? Okay, so it turns out pretty much, I'd say 80% of all statistics classes use the same type of calculator. And that is called a Texas Instruments calculator. You probably heard of those, right? And what I want to make sure is you don't make the mistake that I would say 30% of statistics students make and get marked wrong because of it. And that is not knowing how to read a TI calculator's readout. Okay, and it's going to seem not hard at all, but again, so many people make the mistake. It's so frustrating that I hate having to take off points, but I take off points all the time. I don't even remember the last quarter that I've taught, and I teach statistics every quarter, where I didn't take off points at least 10 different times. So the hope is that I'm going to show you what not to do. And that's a big part of this class, by the way, is to make sure that you don't make the common mistakes people make in a stats class. And I call that Texas notation. Those are my words, by the way, but I got to call it something. You know, it's the notation that comes from a Texas Instruments calculator, but that's too long. So I'm just calling it Texas notation. So I want to ask you, are there any questions about the class or about anything before I start moving? Are there any questions? And again, you can say it or you can pop it into the chat box too. Okay, I would like to give you a moment just in case, because this is question time, and I do want to take questions if you ever have, you know, questions to go. Okay, so if there's no questions, let's move on to, I know this seems silly, but reading numbers. Okay, and announcing numbers. Let me go to backspace, there we go. Okay, so if we have a number, something like 137.928, we want to be able to communicate and, more importantly, be able to understand communication about a number like this. Okay, so the first thing is, anyone know how to read this number out loud? You can unmute yourself and read it out loud. You know, as a full number. I don't see you all jumping in.
I would say 137 and 9,248 thousands, hundred thousands.
Okay, right. This is why I say we need to have number vocabulary, because very people know how to do this, but it's important to be able to read a number. Let me write it out. Right, you were close, by the way. So you started out great. So 137. And 9,048 and the way I like to think about it is, I know there's 9, that's tenths. Does that make sense? Always just to the right of the decimals, tenths. The next one is hundredths. So I just kind of count away. The next one will be thousandths. Add a 0 to get 1,000, right? What happens when you add 1 0 to 1,000?
It becomes 10,000.
Right, so we go 10 thousandths. And that's how you read that number. I want to mention something. You made the mistake, and so does almost everyone else. I want to highlight, or maybe boldface, this word and. When you read a number, the word and has a single meaning and only a single meaning. And that single meaning is decimal place. So you don't want to use the word and anywhere else in a number. Got it? So you don't want to say 137 and 9,000 and 48 10,000s, because you said Okay, so those are just some technical pieces on reading numbers. Okay, I'm not going to get into too much more because that's about it. Maybe I'll do one more example and see if you can get it this time. How about 4 to 9.14, sorry, 1, I don't want to use the same digit, 153. Let's see if y'all can do that.
I have a question. In
Oh,
the
did I miss
last
something?
number, I just
Oh, I did miss it
what?
too, sorry.
Okay.
That's the question. So it's 9,248. 10,000. Sorry about that. Okay, let's see if you can do this other number, which is 429.153 in words. You can type in the chat box, you can write it down, you can say it.
429, oh, 429 and 153 thousandths.
Good, good. So that's 429. Again, it's really hard to keep your tongue from saying and more than once, right? But you want to restrict to the decimal. 429 and 153 thousandths. Any questions on that? Okay, I don't think I need to spend a lot of time on that. Do you all agree that that's good enough, or anyone need to see more? Are you good? Okay, now for rules of rounding. Okay, rounding comes up a whole lot in statistics. Rounding comes up all the time. If you can't round, you will get so many problems wrong. So I want to talk about the rules of rounding, which you might remember or you might not. And the interesting thing is everyone in Japan understands the rules of rounding a lot better. I lived in Japan for a little while. Anyone know why? Anyone speak Japanese? Nihongo wakarimasu ka? Dachi?
I wish I could speak Japanese. I knew your daughter, Hannah.
You knew Hana? Oh, really?
Yeah.
Great.
So she went to school in Japan, right?
Oh, yeah, half the time.
Yeah.
Yeah. So anyway, the Japanese word for rounding, and there's a reason I'm saying it, it's not just trivial stuff, is actually, I'm going to translate it because it won't mean anything if I say it in Japanese, is 4 down, 5 up. Is that a great way of saying it? That's how they say rounding. So everyone knows the rules of rounding because that's how you say rules of rounding. Let me just write that down. 4 down, 5 up. I think that's a much better way of saying rounding, isn't it? Because if you say that every time you say the word rounding, you'll know what to do. Okay? And what that means is that if you're 4 or less, you go round down. If you're 5 or more, you round up. Any questions on that? So now let's try round. How about 249.3891 to the nearest thousandth place? Let's see if you can put in the chat box the answer to that. Okay, good, good. So what you do is you say, first we got to find the thousandths place. And I like to just count. 3 is the tenths, 8 is the hundredths, 9 is the thousandths. So that 9 is what I'm going to decide whether I want to change it or not. And then I look to the right, that's a 1. And then we use the rules of rounding. 1 is 4 or lower, right? So that means we don't have to change the 9. So then the answer, as you can see in the chat box, but I want to type it also, is 249.389. Any questions on that? Okay, next one. We're going to do a bunch of these. Round, how about 23.89723.641 to actually 2 decimal places of rounding, of accuracy. Okay, let's see if you can do that. That's a little bit harder, but not too bad. Okay, good. It looks like you got it. So the idea here is you go to 2 decimal places, and there's 2 decimal places. That 9 is the second decimal place. And then you look to the right, and you say that's a 7. Then you remember rules of rounding. 7 is 5 or higher, right? So that means we go up. Okay, when 9 goes up, it becomes a 10. So that means the 1 gets carried over and the 0 remains. So what we end up with is 23 point, the 1 gets carried over, so that's going to be a 9, because 8 plus 1 is 9. And then the 0, the 9 becomes a 0, because 9 plus 1 is 10. And that gives us our answer. Any questions on this example? What do you think? Do you need more, or do you get the idea so far? Any questions? Because again, I can do more if you want, but again, I don't want to waste your time either. That's not my goal. My goal is to review the easy stuff, but if it's hard for you, I'll spend more time. Okay, so please ask if you want more examples. Okay, now here comes a harder issue. This one comes up a lot. The math is not hard, but the thinking about it is a little tougher. Okay, so what we want to do is, you want one more example. Okay, so let's do one more example. Okay, so round. How about 91.99963 to 3 decimal places of accuracy. Okay, and by the way, if you take statistics at LTCC, and most places also, not just here, you'll be doing your homework online, just like you're doing now. And computers are not smart. They seem like it sometimes, but they're not. So if you make a rounding mistake, but you completely understand the statistics concept, it just marks you wrong. And you get a 0, even though you probably deserve a 95%. But you get a 0, and zeros suck. Do you agree? So this is why you really want to focus on doing these little things right, so you don't get to the point in stats where you really understood the stats and you got a 0 because you rounded it wrong at the very end. Does that make sense? Okay, so again, we want 3 decimal places of accuracy. The third decimal place is right there. So notice a 6 is to the right of that. Sometimes you call that the check digit. And then that means that that 9 goes up. It goes up to a 10, but the other 9 added 1 becomes a 10. And the next 9 added 1 becomes a 10. So the answer is actually 92.000. Any questions on that? Any questions? Okay, so now comes a different kind of example, a little bit subtle, and that is the following. Suppose you want to find out the mean of the numbers 2.4, 2.4, 2.9 rounded to the nearest whole number. Okay, any questions on the question here? Okay, first thing, remember, one of the things I'm trying to do is to get you used to statistical vocabulary. And you may or may not remember what the word mean is. Anyone remember what the word mean is? That actually comes up in, K-12, but it is a statistics word. Yeah, so a nice way of writing the word mean is average. So mean and average are synonymous. Okay, so I'm going to show you the wrong way of doing it. And I'll explain why in a bit. So here's what's wrong. The wrong way of doing it is saying, well, what's 2.4 rounded to the nearest whole number? 2.
Yeah.
Okay, and the next one, 2.4, well, it's still a 2, right? It's good thing about math, this doesn't change its mind on the next one if it's the same question, right? What's 2.9 rounded to the nearest whole number?
3.
3. Okay, then I need to divide by how much? 3.
3.
Okay, when I do that, I get 7/3. Now 7/3, you can stick in your calculator. That's fine, you're never gonna be denied a calculator, by the way. So, if you didn't know how to do 2 + 2 + 3, you can use your calculator, but you probably know how to do that if you need to. Okay, 7/3 is 2.3333, a bunch of 3s. Okay. Now, we're supposed to round to the nearest whole number, so what do you get?
2.
Yeah. So that's a 2. Okay. What's the first word I wrote on this line?
Ron.
Wrong. What's wrong with it? And this is really important.
You're not supposed to round before you do the arithmetic.
Yeah, exactly. Okay. You should never do rounding until the very, very end. Okay. And that's why I wanted to kind of exhibit this because it's a common mistake people make. And again, when you can do your homework on computers, not just in this class, but in stats. And if you make this mistake, you just got a 0. And that sucks, even though you might have totally understand the word mean and how to do it and all that. But because you made this rounding mistake, it'll give you a 0. Let's do it the right way. And we'll see it's different. So the right way is we take 2.4 plus 2.4 plus 2.9 and then divide by 3. Everyone understand what I just did there? Notice I didn't round. You don't want to round at the beginning. What's 2.4 plus 2.4? You might be able to do that in your head. If not, you're always allowed to use a calculator.
0.8.
4.0.
4.8. And 4.8 plus 2.9 is, again, you can use a calculator. 7.7 is what you should get.
Yeah.
Okay. Okay. By the way, that number is very special to me. Any guesses?
Birthday?
Yep, that's my birthday. Yeah, 7/7. Okay. And then we're supposed to divide by 3. Okay, again, you are not required to know how to do this in your head.
2.56.
2.56. Actually, equal. And what do you get? We're supposed to round to the nearest whole number.
3.
3. So notice that it does make a difference whether you round at the beginning or round at the end. And this is a very common mistake that people will make. Okay, so you're probably convinced that the math I'm doing is not new to you. Are you convinced about that? Or maybe it is new, but it's just basic arithmetic. What might be new is the fact that you can't round at the beginning. And that'll get you in stats. Okay, that's what this class is about, is trying to identify the issues that happen, the math issues that happen that will zap you in the stats class, so that when you get to your stats class, you don't make those mistakes. Any questions on this idea? Okay, so that's rounding. Rounding's not too bad. The next thing I want to talk about is scientific notation. Okay, so for scientific notation, a lot of times you need to use scientific notation in statistics, especially in probability, it turns out. Okay, so for example, the probability of flipping a coin 20 times and getting all tails. By the way, do you think that's likely? Without cheating, it's a fair coin. Do you think you'd be surprised if that happened, if you tried it today? I would guess that you wouldn't think it's likely, because it's very unlikely, but let's see how unlikely it is. It turns out it's 1 over 2 to the 20th power. Whoa. 1 over, oh, it's auto changing. Control Z, there we go, to the 20th power. Okay, by the way, I'll write it this way because I want you to get used to how you're going to type things in a calculator. So what I want to do now, I'm going to copy this. I'm going to go to, I'm not sure if you realize that Google's very smart. That if I paste it in there, it just gives you, I don't have to do anything. I just type it in. It knows. And so is 1 over 2 to the 20th power about 9.5 rounded to 1 decimal place? What do you think? That's Google. Google's smart. So to the 1 decimal place, is it 9.5? What do y'all think? Okay. So here's the thing. This is why I'm doing this, because 30% say yes, and it's a no. Okay, there's something really wrong with this. Let me make it show up again. And what's wrong with this is that we need to read the number, the whole number, and understand what it is. So this is it's not quite the Texas way, because it's the Google way too, although Texas uses capital E. Google uses lowercase e. Okay, and you see this E-7. Do you see that? Okay, you're going to see this on the TI 84 calculator also. And that means scientific notation. Got it? So let's write, I'm going to write this, I'm just going to write some of it. Actually, I read on paper. Actually, I can do it this way. I know what I'll do. Do it that way. And then I can copy and paste. I think it'll let me. There we go. Better. Okay, so there's what Google told me. And again, the TI will tell you the same thing with a capital E instead of a lowercase e. So how do we interpret this? What does that -7 mean? Okay. So it's not quite add 7 zeros, but it's a good idea. You're close. Okay, what it means is move the decimal place. So I'm going to put a whole bunch of zeros in, and then I'll put the 9.5367436. So I'm just going to write that out, and then we're going to make the e to the -7 happen. So to make the e to the -7 happen, what I need to do is I'm going to need to take that decimal point and I'm going to move it to the left 7 places. Notice the first movement doesn't add a 0. Do you see that? The next movement does, as the next and the next and the next. So what you're going to end up getting is you're going to move that 7. Let's see, 1, 2, 3, 4, 5, 6, 7 is right there. And that's a new decimal place. So notice there's 6 zeros, not 7. So this is how you write something, and then we can get rid of all these other leading zeros. So I write a whole bunch so that I know I'll have enough at the end. So you'll notice, by the way, there's a very low probability of flipping a coin 20 times and getting all heads. Do you believe that? Okay. So why there's 6 zeros? Because the first movement doesn't give you a 0. So for example, let me give you another example. What if we had 5.432 e -1? I'll do it in Texas notation, which is capital, but that shouldn't matter. Well, that dot moves over 1. There's no 0 there. Do you see that? It just goes to the left of the 5. So that would be equal to 0.5432. There's no zeros. Do you see that? Okay. Any questions so far on this little example? Let me do one more. That's not going to use a negative. It's going to use a positive. So what if we had 3.426? I'm going to use Texas notation, capital E, 8. What's the difference?
You're gonna move the decimal point to the right 8 times.
Yeah, exactly. So now we're going to move the decimal place 8 to the right. And what I like to do, I can always pad in as many zeros as I want. Okay, because it's on the other side of the decimal. So I'm always allowed to do that. And then I'm just going to count. So again, I'm going to start at the decimal place. And then it's going to go 1, 2, 3. Notice the first 3 movements are before we hit the 0, right? We're going to have 5 more movements, so we can get 5 zeros. And the answer will be 3, 4, 2, 6, and then 5 zeros. Okay, anyone know how to read this number? And it helps in English to put commas. Much easier to read if you have commas. How do we read that?
342,600,000.
Good. 342,600,000. Okay, and that's how you deal with scientific notation. And again, when you learn in, whenever you learned it in middle school or high school or whenever you learned it, you learn it with a 10. Anyone know why you're not seeing a 10 on Google or the calculator? Okay, the reason it would look really weird. Let me put it here, because then it would look like 9.5367431 10, -7. Isn't that a lot harder to read? It's just you don't see it. It looks like you're subtracting 7, doesn't it? From that number. So there's a reason why they use E. And the reason is because it just doesn't look right on a single line without writing a times sign. But times signs are weird on a calculator. So that's the reason why they do it. And actually the letter E is short for exponential. You don't have to know that, but it's a little trivia. That's about all I need to say in terms of math. Today's gonna be a shorter one. Don't get used to this. Usually they'll be an hour, but we did the orientation yesterday. So because we did the orientation yesterday, I didn't want to like kill you with too much math this week. So this week is lighter on the math. So next week will be more math, but there'll be no orientation. You'll be used to the class already, hopefully. So that's all I have to do, but what I've not told you yet, that's really important, because it's not math.
We need the secret word.
You need the secret word. And the secret word, I don't need to look, is Eve. And remember what that stands for? Enhanced virtual environment. Okay, and that's what they're calling every other class except this one. This one's a truly online class, but all my other classes that I'm teaching are online, but we have to pretend they're not because students thought they were taking a regular class, whereas this is a truly online class. So that's why I put that in, just in case you're curious. If you're taking any other classes at Lake Tahoe Community College and you thought you were taking face-to-face, you're not. I don't know if y'all know that. Or any other college in probably the whole country, that every class is online now. But they're calling them, they have this fancy name, Eve. And that is the, so that's the secret word of the day, because that's kind of what's on everyone's mind right now, is the fact that we're stuck at home and we can't go to the college anymore. At least that's what's on my mind. Or we can't go anywhere else except the market. So I want to show you something, but don't say it, because once I've given it, I don't want people to just scroll to the end of a video and look for the word and say, I got the video done. What you're going to be doing is, if you go to the modules, you will see in week 1, should be there. Oh, I didn't put it in yet. Well, you'll see it in a minute, which is fine because you weren't ready then. It's a good thing I checked, or you'd be really confused.
Mhm.
There we go. You'll see week 1 secret word quiz. What you'll need to do is you need to click on that. It won't look like this. It'll look like this, because you're not the instructor. Whoa. I need to fix that too. Just a minute. That's not what it's going to look like. How did that happen? Sorry about that. Because I made a multiple choice and it's not supposed to be. If you already did the quiz, then you got it. Because it was already there. It wasn't supposed to look like that. Let me go to blank. Don't want fill in the blank, no text. I think it's fill in the blank. I'm gonna check them all. Yeah, there we go. Okay, so when you look at it, this is what it should look like. It says, what was the secret word for week 1 webinar? You type in the word, which I'm not going to say because I want people who are watching this to watch the whole thing. And then you hit submit quiz and you should get it right. Okay, so we're done. But as always with any, let me go. With all the webinars, I'm always happy to take questions if you have questions. But you're welcome to say goodnight too. Again, this one's shorter than usual. Took a little longer because I got stuck on that quiz. Sorry about that. But I'm happy to answer any questions you might have. And I'm also happy to say goodnight too, if that's what you know, if you don't have questions. And by the way, if you have any suggestions, were the other videos getting fixed? I have not received word from Roy, who wrote the video, and he's the only one that can fix them. I don't have permission. So I have a feeling they're not going to get fixed. And what I'll do is I'll just remove it. So don't worry about it. If they do get fixed, I'll let you know. If they get fixed in the next day or so, then that's enough time. But after that, it won't be, then I'll just take them out. So sorry about that. But again, I'm always happy to answer any questions if you have them. That could be math questions. It could be questions about the class, or I don't know. My last class, they asked questions about when this thing is going to be all over. How many months is it going to be before we actually get to regular life? And I showed them some mathematics about it. But I'm happy to answer any questions if you have them.
Thank you. Good night.
All right, thank you, and have a good night. Let me stop recording.